So here, a polynomial, I just took that part off that I should have taken off. So a polynomial also is reducible if it's not irreducible. So in other words, it has a factorization that is not trivial. You can factor it and it's not a trivial factorization. Then it's reducible. And you might be asked also to factor a polynomial completely. That means you're writing it down as a product of irreducible factors. In other words, when you factor a polynomial completely, you're going to factor it until you can't factor it anymore. And it turns out you can always factor a polynomial completely. You could write it as a product of irreducible factors. Now, why can you do that? That's way beyond the scope of the course. But for now, I guess we'll have to accept that you can do that. I mean, the first time I ever saw that, why you can do that, what did I say? I think in graduate school, if I remember correctly. All right. So that's just some vocabulary that's good to know. Okay. You know, again, because the test of take home, I'm not going to ask you for, vocabulary quiz. Not going to do that. But still good to know vocabulary here. All right. Okay, so let's do some other examples. So here, let's consider this trinomial. And here you can probably see why it's good to get the GCF out first. For instance, here, notice the smallest exponent of x is 1, right? That's the smallest exponent of x. Now let's look at the coefficients also. Well, if we were to list the factors of them, 30, we have all this. If you look at all the factors, 25 is all this. 155 turns out to be these. It actually turns out to be 31 times 5. So, but hopefully you can see that the greatest common factor among the coefficients is just 5. I mean, once you know a factor, you just keep on dividing to get all the factors. And you do that for each number, and we can see that the greatest common factor here is 5 of the coefficients. So the GCF then is 5 times x. B is 5. Let me write that. B, oh boy. B is 5, and M we have is 1. So the GCF then is 5 times x. So let's factor that out. We put it in front. We have to divide, right, into each term. As you can see, we end up with this. We get 6 times x squared, right? This is just the same calculation from before. We get 6 times x squared. 30 over 5 is 6. X cubed over x is x squared. 155 over 5 turns out to be 31. X squared over x is x. 25x over 5x, that just turns out to be 5. The x's cancel. And 25 over 5 is just 5. And now what we would have to do is factor this here. And you can see how much easier it is, right? The numbers are a lot smaller. I would not want to do that AC method directly on this. 30 times 25, then you have to find factors that add up to 155. Negative 155, I mean. That might be a little tedious. Here the numbers are a little smaller. And that's because we factored out the GCF. Makes it a little bit easier. Okay, so let's handle this. So again, here, just like before, our capital A is the coefficient of x squared. which is 6 in this case. B is minus 31. You have to include the minus sign. Don't forget to do that. C is 5. So I wrote that over here. Okay, that's good. Now we can see that A times C is 6 times 5, which is 30. We want two numbers, and B is negative 31. So we want two numbers whose product is 30, and the sum is negative 31. Now, based on the other example, you might say, oh, well, 5 and 6 work. Well, no, they don't. The product is 30, but the sum here is 11. So 5 and 6 are not going to work. What about 30 and 1? Close, but no, because 30 plus 1 is 31, not negative 31. We want negative 31. Well, how about negative 30 and negative 1? That works, right? If you multiply two negatives, you get a positive, sap and sun rules. So we're going to use negative 30 and negative 1. Okay. So what do? Like before, as before, we have to replace the minus 31x, right? The minus 31, excuse me, with minus 30 minus 1. I wrote it as a separate step here. And then, of course, just like before, you distribute the x like so, right? And doing so, you get minus 30 times x minus 1 times x, which is the same as this. And so I replaced minus 31x with this difference. And that's what I did here. Okay, we replaced it. And so what we have to do is apply factor by grouping on this thing. Okay, even though I wrote the GCF as 1, again, we can really skip. You really don't have to find the GCF unless I ask you to. That's a good way to say it. Even though it's really good to find the GCF here, it does turn out to be 1, mostly because we have a coefficient of 1 and a non-zero constant term. As we've seen before, in that case, the GCF is going to be 1. Okay, so what do? We have to form those two groups, right? Notice also that the second and fourth term have opposite signs. So we will have to factor out a negative from our second group. And how do we make the groups? Well, again, I always recommend having addition between the second and third term, as I'm doing here. Makes it easier, and you're less likely to make a mistake when you form these two groups, as you can see. Okay. So we have our two groups. Okay, so now we have to factor each one. And as I said already, the second and the fourth term have opposite signs, right? This is minus, this is plus. We will have to factor out a negative from the second group here. Okay, so for the first group, let's handle that first. We can see that the smallest exponent of x is 1. So m is 1. 6 is a factor of 30. So 6 alone is the greatest common factor of 6 and 30, the coefficients. B is 6. B times x to the m is then 6 times x. So we factor it out. How do we do that? Put it in front and divide. And when you divide, you have to divide into each term in a difference or a sum. So we divide to each term. And when you do that, the 6's cancel. x squared over x is just x. For the second one here, 30x over 6x, well, the x's cancel. 30 over 6 is 5. That's for the first group. For the second group, well, you have negative x plus 5. Okay, well, excuse me, we have a non-zero constant term, so m has to be 0. Okay. Negative 1, the only factor of negative 1 and, excuse me, the only factor of negative 1 is 1 itself. So the only common factor negative 1 can have with 5, or any number really, is just 1. So the greatest common factor has to be 1, and the GCF of the second group is also 1. But again, we have to factor out a negative, as I said already. So I'm factoring out negative 1, and that's what I'm doing here. Okay, I really want to finish this, so let me keep going. So basically, again, you're just dividing negative 1 into each term, and this is what we get. And so basically, in parentheses, the common thing is x minus 5, as you can see. And then we just pull that out. And when you pull that out, from the first here, you're left with 6x. From this here, you're going to be left with a 1. And that's what we get here. And now, using the fact that the original thing was 5x, that was the first GCF, we get 5x times x minus 5 times 6x minus 1. And that's the factorization. And again, if you wanted to see more steps, I'm just showing more steps here. Basically, to factor out x minus 5 is just like before. You divide, and when you divide into each term, and then, you know, there's cancellation. Again, I know these steps might be confusing, but I know some students like to see them, so that's why I throw them in. All right. Okay. All right. Yeah.
Professor Ornstein, when you have a polynomial that's like ax squared plus bx plus c, and you have to factor it, how do you know if you're using the AC method or just regular factoring, finding the GCF?
I mean, the GCF you want, I'll tell you which one to use to factor, which method to use, but generally you want to use the AC method.
Okay, thank you.
Does that help? Or, oh, you're welcome. I hope that helps. Good question. I know factoring is not easy. Believe me, everyone, I understand that. Okay? You know, I was a student once myself. I know this is not easy, okay? But I really want everyone to learn this. So, I mean, we're at a time now. So I will see you on Wednesday. If not, I mean, you can always email me if you can't make office hours. Although tomorrow, I'm not sure if I have office hours or not because it's a wellness day. But I'll let everyone know. So see you on Wednesday.